Okay, starting chapter 3. This first section, this whole chapter actually, is about derivatives. So let's take ourselves back to chapter 1 and remember what we learned that a derivative was. Derivative. And if you remember, that was our rate of change. At a point. And we had two ways we did this. The first way we did it, we did it with a 2-point table, and then we went to the 3-point table because it was more accurate. So I'll just put down the 3-point table. Where we did, say if it was at 2, we did 1.99, 2, 2.01, change in y over change in x and average. And the other thing we did was we counted the slope of the tangent line if we didn't have the equation to get the values. So the slope and the 3-point table both gave us values for the rate of change. And both of these were ways that we estimated. They were estimates. In this chapter, we're going to find the how to find the derivative exactly. So we'll start out with the definition. So the definition of derivative at a specific c value. Okay, and this is our instantaneous rate of change. It's no longer going to be an estimate. It is going to be the instantaneous rate of change. Rate of change, ROC, we'll go with that. Okay, and first of all, the notation we're going to be using for derivative is a prime. It's called f prime of c. That means find the derivative at c. So we're not going to use the words too much anymore. We're going to use using symbols. And the definition has a limit in it. And that's why we did a whole chapter on limits. It's the limit as x approaches c of f of x minus f of c all over x minus c. Okay, and I want to show you in a picture why it is that way. So if we had a function and we wanted the derivative at c, what we did was we took a point close to c, another x value. So this one's f of c, this one is f of x. And to get that slope, we did change in y. The change in y is f of x minus f of c, f of x minus f of c, all over the change in x, x minus c. And we want the limit as we slide this x in closer to c. As I slide it in, what do those slopes appear to be approaching? And that's what this definition is going to tell us. So this little quotient here is called the difference quotient. Difference quotient. And all it is a change in y over change in x. It's doing the slope of the tangent line at that value of c. So let's see how this works. Oh, I still want to see that definition there. So our first example, if f of x equals 2x squared plus 5x minus 2, let's first estimate the derivative at 2, our old way, and then we'll find it exactly using our new way. So first thing I want to do is sketch. Squared plus 5x minus 2 okay. And we're going to estimate the derivative at 2. Let me just do this. So our goal is to estimate the derivative there at 2. So what we're going to do first is use our Chapter 1 estimate. So estimate the derivative at x equals 2. And let's just do our 2-point table instead of the 3, because we're not going to be doing this much anymore. So we've got 2, and I'll go 2.01. 2.01. So at 2, the graph is up at 16. And then at 2.01, it's at 16.1302. So now my derivative, change in y, 16.1302 minus 16. Change in x is 0.01. It's going to give me 13.02. So that was our estimate stuff. Now let's see the process to get it exact. So, I don't know if I can fit this in here. I don't think I can. Oh, I'll just put another piece on here.
People, make sure you get things out of your lockers. Hall decorating will be covering your lockers. Get everything out of your locker that you need. It will not be available.
Okay, now we will find the instantaneous rate of change using the definition of derivative that we had up here. So we're going to find f prime at 2. That means the derivative at 2 is, and I'm just going to use this definition from up here, it's the limit as x approaches 2, the limit as x approaches 2 of, the definition says take f of x. That's your equation in terms of x. Well, my equation in terms of x is 2x squared plus 5x minus 2. And the definition says subtract f of c. Subtract. The biggest mistake I see people make is they take the c value and put it there at 2. No, that says subtract f of 2. So off to the side here, f of 2 means you're going to plug 2 back into your function and get that value. So f of 2 is 2, plugging 2 in, 2 squared, plus 5 times 2, minus 2. Oh, we did it up here. We plug 2 in, we get 16. So I'm subtracting 16, not the 2. You got to plug the c value into the function. And then we divide by, and on the bottom, it's just x minus your c value. So it's x minus 2. So now I can do a little simplifying here. So it's the limit as x approaches 2 of 2x squared plus 5x, and I'll have a minus 18. Remember, to get a limit, we're going to plug the x value in. If I do that, I'm going to get 2 times 2 squared plus 5 times 2 minus 18 over 2 minus 2. Let's see, 4 times 2 is 8, plus 10 is 8. I'll get 0 over 0. And remember, when you get that 0 over 0, that's a removable discontinuity, and you can remove it by factoring. So if I go back, and because this is only a quadratic, I don't have to do the synthetic division, I know x minus 2 is one of the factors, so that's what's going to cross off. The other one, remember when I multiply first times first, I'm going to get 2x squared. So that has to be a 2x. And last times last has to give me that negative 18. 9. Now I can cancel. Now my limit can be found by plugging 2 into the remaining factor. So I'm going to go 2 times 2 plus the 9. 4 plus 9. 13 is the exact derivative at 2, where we got that approximate 13.02 with the 2-point table. So there's lots of algebra in here. The algebra will be the challenge, but it's just follow the formula. Biggest mistake is right here. Make sure you put your x value into the equation and put that there that you're subtracting, not this number. Let's practice another one. If f of x equals x cubed, we want to find f prime of 3. That means the derivative at 3. So f prime of 3 equals the limit as x approaches 3. And that definition said, I'll even write it out, f of x minus f of our c value all over x minus the c value. Now I'll plug in here and here. So it's the limit as x approaches 3. F of x is my equation, it's just x cubed, minus f of 3. F of 3 means you plug 3 into the equation. 3 cubed is 27. I'm subtracting 27, not the 3. All over x minus 3. Ready for the limit. If I plug 3 in, I'll get 27 minus 27 over 3 minus 3. That's that 0 over 0, so we have to factor. So I know one of the factors is x minus 3. But the other one, because this isn't quadratic, I'm going to have to do that synthetic division. Do your little Gazinda thing. So we take the opposite of this number, or you used your C number. So we're going to take 3 and divide it into, and we're dividing into x cubed. Excuse me, right here, x cubed minus the 27. So I've got 1x cubed. I need a 0 placeholder for the x squared, 0 for the x to the first, and then I've got a minus 27. And remember, this should come out 0 here if I do this right. So raise the first one, nothing here, multiply, add vertically, multiply, add, multiply, add. Okay, that tells me my other factor is 1x squared, one less than that, x squared I said, plus 3x plus 9. Now I can cancel off my common factor. Now my limit, which is my derivative, will be whatever I get when I substitute the 3 into the remaining factor. So 3 squared plus 3 times 3 plus 9. Plus 9, 9, and 9, that's 27. Derivative is 27.